exercise dalam nota saya? Ada soalan yang tak boleh buat?
Setakat ni boleh buat lagi.
Tak ada soalan salah?
Yang tu tak pasti.
Anybody identify anything? No? Okay. Not on this. I didn't copy it because it's simple. If you look at my exercise, 1 second. It's hang. All right. Are we still? Am I still there?
Yeah. Yes.
Okay. That one. Sorry, I got 4-hour class in a row. So my laptop macam marah kat saya. All right. I'm back and I hope you can listen. I'm sorry. Okay. Okay. There is some correction that I want to make. If you realize, I don't know whether you realize or not, for the exercise 1.11 in my notes, okay, question number 2A. Let me copy the question first. The question is this. Rate equals to negative dNO dt. Kalau kamu buka soalan ni, dO2 dt plus 1/2 dNO2 dt. Alright. And if you write the equation, I believe your equation should look something like this. NO gas plus O2 gas forming 2NO2 gas. Betul? Dapat yang ni? Kan? Betul ke soalannya? What is wrong with this question?
Balance the equation.
It's not balanced. It's my bad. Bukan salah kamu. Saya terima sahaja siapa yang tak balancekan dia ya. Siapa yang tulis yang ni sebagai jawapan sahaja saya terima sebab yang ni yang diberi. Betul? Yang ni yang diberi. Okay, so saya terima sahaja yang ni sebagai jawapan. But if you look very carefully and very closely, you realize that my question is something wrong somewhere. Okay, the equation is not balanced. So take a quick look lah. Okay, kalau tak ada masalah setakat ni, saya nak jimat masa sikit sebab kita dah start sikit tadi. Saya bagi kamu bagi jawapan calculation yang akhir and kita check betul atau salah je lah. Yang ni adalah exercise 1.11 soalan 3 kalau tak silap saya. The rate differential equation above, saya boleh bagi yang ni. Rate, make sure ada perkataan rate. Negative 1/2 dNO2.
Not balanced equation.
Plus 1/2 dNO dt. Alright, equals to positive dO2 dt. Okay, ni adalah jawapan dia. Alright. Untuk B, can anybody give me the final answer of your 3B? 3B ya? Not 3. Soalan mana ni? 4. Sorry.
Question 4.
Question 4. B. Anybody can give me the answer for B? Just the final answer.
0.166 ms negative 1.
0.166 ms negative 1. Okay. Kalau ada yang tak setuju dan bagi tahu, saya akan kira lah. Okay. Alright. Next, kita pergi kepada soalan seterusnya. Question 5. Okay. At what rate the NO2 is being formed? Your A. Anybody?
.0.047 ms negative 1.
0.047 ms negative 1. Just a kind reminder, saya terima yang ni sebagai jawapan. Make sure bila kamu tulis jawapan, soalan ni adalah rate of NO2 being formed. So make sure kamu ada positive NO2 dt. Jangan tinggal jawapan kamu tak ada kepala. I always tell my student, don't leave your answer untitled. Kamu suka buat macam ni tau. Kamu ada kertas, kamu suka buat sama dengan dari awal sampai hujung sama dengan. Tapi sama dengan apa tak tahu. So never leave your answer untitled. Make sure you have what is that for this answer. Okay, check your work. And then your B. At what rate the molecular geometry, molecular oxygen reacting? Reacting means the oxygen will be decreasing. So I suppose it should be a negative dO2 dt. Answer?
Zero point zero two three five
0.0235
molar
ms
second.
negative 1.
Thank you. All right. Thank you, Alia. Thank you, Ani. All right. You have your 0.0235 ms negative 1. Agree so far? Okay. Tak ada apa. Senang je. Question number 6 if I'm not mistaken. Over here kita ada A dengan B. Sama juga dalam A dengan B saya. Just to make sure you check your answer. Ammonia being formed means I need to have positive D ammonia over DT for the A, and for the B adalah reacting. So dia adalah negative DN2 DT. So atas jawapan kamu selain daripada value yang kawan kamu nak bagi ini, make sure kamu ada the title. Never leave your answer unattended. Okay, never. Can I have the A? Saya duk dengar suara perempuan je, so kita bagi budak lelaki pula. Alif?
0.049 ms -1.
0.049 ms -1. Alright, 3 decimal place boleh. Lim?
For B, 0.0247 ms -1.
-1. Unit semua standard lah. Betul. Okay. So far so good. Senang je kan? So yang ni pun tak ada apa. Rate expression. Express the rate in term of change in concentration with time. So this is actually another sentence for your rate expression. Okay. Express the rate in the change in concentration with time. So your A is basically your differential rate equation, where make sure you start off with the rate, -1/2 D hydrogen gas, D concentration hydrogen gas, equals to -D concentration oxygen gas, equals to +1/2 DH2O dt. Simple. Okay, tak ada isu kat situ lah. And I'll just give you the answer for this one. For your H2O increasing, positive DH2O dt. Correct me if I'm wrong. I got it here 0.46 ms -1. Jawapan saya tak sentiasa betul. Kalau kamu nak tahu, saya selalu buat kerja ataupun fikir when I was driving, when I was doing my, you know, on the sofa or whatsoever. So kalau jawapan saya salah, bagi tahulah, kita belajar. Okay, don't trust it 100%. Okay. A, tak ada apa, formation of the NO, kalau semua boleh buat, just very quickly checking your answer. Over there, saya ada 0.016 ms -1. Saya pun conteng merata, saya pun kena cari jawapan. DH2O dt. Alright, saya pun kira macam tu je. So correct me if I'm wrong. For the B, negative DNH3 dt equals to 0.016 ms -1. Betul? Okay. Saya rasa nak kira tu tak ada masalah. Yang ni lah yang kamu suka tinggal. Ni lah yang kamu suka tinggal. Budak memang suka tinggal jawapan tapi tak ada kepala. Saya pun tak tahu kenapa. But that is your habit. So don't do it. Okay? So, happy with that? Simple. Something very simple to start off your very first class on Monday. So, benda senang. Kalau keluar exam, satu je. Jangan buat careless. Hampa benda senang, hampa buat careless dan hilang markah. Benda susah, hampa tak boleh buat dan hilang markah. What do you want in your life, weh? What do you really want in your life? That is a question, you know, that is a big question. Apa yang hampa nak sebenarnya? Aku bagi soalan senang, hampa buat careless. Aku bagi soalan susah, hampa tak boleh buat. Nak apa sebenarnya? Okay, going into rate law, okay? A quick question before we start off with the rate law. Another name of rate law adalah rate equation. Just a quick one for you. Rate law also will be called as your rate equation. So nampak beza ya? That is your rate expression. This is your rate equation. And when the term stated that is an equation, which means you're actually having a formula. You're having an equation. Okay? I'm giving you a very simple, let us try straight away with ammonia. Kita biasa buat ammonia. Okay? This breaking of ammonia, tak nak, formation of ammonia. Okay? Let's say I have a formation of ammonia over here. And then I form my ammonia. Okay. And for this one, I want to write both. If I am writing my differential rate equation, yang kita baru belajar tadi, yang kita baru habis bincang. Okay? For this one, how do I write? We are going to take everything. If you remember, we are going to start off with the word rate. I am going to take my reactant, negative DN2 dt. Alright, I am going to take my reactant, negative 1/3 DH2 dt. Alright, and I'm going to take positive 1/2 D ammonia dt. So far so good? Agree? Okay. My next question yang kita nak fokus. What happen if the question is asking for rate law. How do I write rate law for this equation? Anybody want to try? Okay, before we write, first question. Bagi tahu dulu apa yang sama. In the writing, in the way of writing the equation and the expression, yang sama adalah rate. The rate that you have in both differential rate equation and your rate law, dua-dua rate kat situ adalah rate of reaction. Dua-dua rate tu adalah equation punya, reaction punya, yang penuh, dia punya. Okay, yang semua. Dua-dua tu adalah rate of reaction. Settled. Okay. And then in the rate law, the differentiation, yang paling ketara, do we take count of everything in the rate law? Do we take everything in the rate law? We only take what? If you realize the main thing, the main difference is in the differential rate equation, we take everything. Semua produk dan reactant. Tapi in the rate law, if you realize, guys, we only take count of the concentration of the reactant. Perasan? Sebab tu, perlu tak tambah tolak? Perlu tak positive negative? No. Why we don't need the positive over here? Why we don't need the negative over here in the rate law? Because we know that in the rate law, we only take count of the reactant. In the other words, everything that in the rate law would definitely be your reactant. Make sense? Sebab tu dia tak perlu simbol negatif dah. Kita dah tahu kita hanya ambil reactant. Perubahan paling ketara, the first one. The second, do we take count the stoichiometry in the rate law?
No.
No, Lim say no. The stoichiometry for your differential rate equation, kita ambil kira. Alright? That's why we badly need a balance equation. We basically must have the balance equation before that. But over here, we are not taking count of the stoichiometry. That's why I cannot put a 1 or a 3. And in your notes, we always use a different word. X, Y, W, Z, P, Q. Sayang gunalah apa pun yang hang suka, tapi dia bukan benda yang sama atas soalan kamu. Okay? See the difference? Two things. First thing, in the rate law, we only take count of the reactant. Second thing, do you realize that we do not take the stoichiometry? Yang ni kena ingat dalam kepala. Jangan ambil stoichiometry, please. Okay? So, we are pretty much done for the rate law, and the main thing for this slide is, saya nak kamu nampak beza dia. Okay, saya nak kamu nampak beza dia. Yang tu yang paling penting lah. So, next thing, going into your rate law, ada apa, tak ada apa. Okay, that is your rate of reaction. Masih adalah molar per time. Yang ni tak ada apa. Negative 1, that is still the concentration. In molar, nothing much. Okay, dua-dua ni adalah concentration in molar. So, nothing much. My question, a quick one. Apa itu K?
Rate constant.
Rate constant. Apa itu X, Y?
Reaction order with respect to.
Reaction order. Anybody want to try? Apa itu XY? Okay. Kalau kamu kata reaction order tadi, untuk teacher, reaction order adalah X tambah Y. Okay. X tu apa? X adalah order with respect to N2. Yang tu adalah X. Dengan kata lain, this is order of reactant. Nampak beza? Order of reaction adalah total. Dengan kata lain, reaction order, kita akan masuk ke order juga nanti. Reaction order adalah total. X tambah Y. Yang ni adalah reaction order. Tapi X dengan Y individual adalah order to the reactant. Alright, order of that particular reactant is different. Okay, it's different. Depends on the question apa yang dia tanya. Okay, boleh beza? Just very quickly. Boleh beza rate law dengan differential rate law? Yang tu yang paling penting. Kena boleh beza. Okay, next, rate constant. Knowing that your rate constant today, okay, is K. So anybody can tell me anything special about rate constant? Anyone? What do you know about rate constant? What do you understand about rate constant? Is that a fixed value?
Dia punya unit ada varies. Depends on X
Unit.
dan Y.
Unit will be various. Depends on the order of reaction. Reaction ya, bermakna dia akan depends pada total order. Okay, tengok beza ya. Bukan X plus 1 Hani cakap tadi betul, tapi bukan based on X and Y, based on both of that, total of that. Okay, dan soalan saya, misconception Buddha is whenever you heard of the word constant, you always come into your mind is the value is fixed. You know, like gas constant 8.314, 0.08206, or your Avogadro constant 6.02 times 10 to the power 23. Whenever student come across the word rate constant, in your mind you will be like, oh, it's a fixed value. No, not in this case. Your rate constant over here is not a fixed value. Alright, it's never a fixed value anyway. Because your rate constant will change depends on the reaction. Every single reaction will have a different rate constant. Guys, bukan setakat reaction yang berbeza. Kalau saya ada reaction yang sama tapi pada suhu yang berbeza. Kalau saya ada reaction yang sama tapi pada suhu yang berbeza, dia still akan ada rate constant yang berbeza. Okay, simple. We look at your rate law. Your R equals to K X B Y, katakan. Nampak tak your rate constant will be affected by your rate? Betul? Alright, ataupun bahasa lagi senang, nampak tak dia directly proportional? Okay, kalau kadar tinggi, kalau rate of reaction tinggi, concentration tinggi. Rate constant akan tinggi, betul? Kalau R tinggi, K akan tinggi. Make sense? And yang paling penting sayang, kat topik 1.3 hujung topik ni nanti, kita akan belajar factor affecting rate of reaction. Kita tahu concentration tinggi, R akan tinggi. Kita tahu kalau ada catalyst, R akan tinggi. Kita tahu kalau temperature tinggi, R akan tinggi. Betul? Ada kan benda-benda tu? Dah masuk lab belum? Alright? Belum masuk lab. Kita akan buat benda ni dalam lab nanti, minggu depan. Okay? So, bila suhu naik, rate tinggi, kadar tinggi, benda tu cepat berlaku. Bila benda tu cepat berlaku, K akan berubah. So, your K value will never be a fixed value. It will change. Even though it's the same reaction, but different condition. Okay? So, be very careful with that. Dengan kata lain, kamu boleh kira lah. Okay? Kamu boleh kira. And your friend over here say unit is various. So, let's see how much you know. If I have order, or I would say total order, selalu tinggal dan budak pun tinggal lah macam saya tinggal. Total order of reaction. And then unit K. Alright. If the total order is 0, anybody?
Molar time -1.
Molar times time -1. Thank you, Umi. Kalau dia adalah first order?
Time negative 1.
Time negative 1. Thank you. Kalau the second order,
Molar -1, time -1.
molar negative 1, time negative 1. Okay. Apa jadi kalau dia fifth order? Nabila?
Molar -4, time -1.
Molar negative 4, time negative 1. Apa jadi kalau dia adalah eighth order? Alif? Tadi Alif nak buka mic.
Molar -7, time -1.
Perfect. Can you see the trick? I can show you how to derive. Even later, when we start doing question, I can show you how to derive. During my time, when I was a student, we need to derive this. We need to prove that why the unit work like that. Why the unit is like that. But in your moment, since kita tak payah derive, so saya pun tak payah tunjuk banyak. Saya nak tunjuk satu je. Benda pertama yang saya nak tunjuk, semua adalah per time. Realize that? Okay, yang tu selesai ya. Semua adalah per time. Yang kedua yang saya nak tunjuk, look at the molar. The molar is actually minus the order. Satu, okay, molar sentiasa bermula dengan satu. Satu tolak zero, satu. Satu tolak satu, first. Satu tolak satu, kosong. Tak ada apa tinggal. Okay. Satu tolak dua, 1 minus 2, negative 1. Nampak? 1 minus 5, negative 4. See that? Okay. So tak payah pun, orang kata apa, tak payah pun derive macam-macam. Okay, tak payah derive, buat cara tu je. Cuma yang saya nak ingatkan satu kat sini adalah, be very careful, the unit K will be 100% depends on the total order. In the other words, the unit K will depends on all your X, Y and whatsoever. Okay? Contoh soalan. If I'm having my rate equals to K, concentration A, concentration B, and concentration C. For this question, what would be my K unit? Amira?
M -4, time -1.
M -4 time -1. Anybody else? Or everybody agree?
M -5, time -1.
Alia kata M -5 time -1. Okay, siapa group Alia, siapa group Amira? Ni cepat ni nak berpolitik saja, tak adalah. I'm not a big fan of politics because it doesn't work. Oops. Ada anak datuk ke? Anak menteri? Saya salah cakap pula. Kalau ada anak datuk, anak menteri bagi tahu weh. College kita macam banyak benda kekurangan. Kekutlah ayah nak bagi apa-apa ke kat kami. Kedekut gila cikgu ni. Tak betul lah kan? Hampa pun duduk KMPP apa tahulah college kita macam mana kan? Tak payah aku nak cakap. Okay? My tanam satu fiber optic kat college kita ke, that will be like the best thing ever. Betul. I will call your dad. I will call your dad also. Alright, where we are? Okay, -4 or -5, which one?
-5.
-5. I'm -1. Okay, sorry. -5. Sebab apa -5? 3 tambah 2 tambah 1. So the total order kat sini adalah 6. The total order adalah 6. When the total order is 6, the unit K will be M -5 time -1. Simple. Boleh buat? Easy. Alright, very easy. Question on rate constant? No? Okay, no question. I have question. Alright, my question never stopped, by the way. If the question started off with this, I give you the K value and you need to identify what order is that. Let's say I have a reaction K equals to 0.0715 mole negative 2 liter 2 minute negative 1. Order of reaction?
Third order.
Kenapa kamu tahu dia adalah third order?
Mole negative 2.
Mole negative 2, positive 2. Mole to the power of negative 2, liter to the power of 2. Kat sini sebenarnya melambangkan molar negative 2. Okay? Just a kind reminder. Bear that in mind. Yang kamu suka guna M, betul. Semua orang suka guna M. Saya pun suka guna M, betul. Senang. Tapi benda yang senang takkan keluar exam. Always remember that. Okay? Our job is to make your life hard. Kalau soalan exam semua soalan senang, soalan tu tak ada quality. Okay? That means your lecturer is not doing a good job. If your life is not hard when you come into my class, I'm not doing a good job, you know? Your life need to be hard. That means I'm working. So, need to remember this. Molar is a mole per liter. Ataupun is a mole decimeter cube. So, bila dia terbalik, ladies and gentlemen, to the power of 1, dia akan jadi mole negative 1 liter to the power of 1. And when it's terbalik, 1 over, this will be mole negative 1 decimeter cube sahaja. Tak ada per. Nampak beza? Okay. And what would happen when is M, let's say, negative 4? Apa jadi kalau M negative 4? Kalau M negative 4, yang ni dia jarang keluar dah. Dia jarang keluar dah. Dia akan main kat sini. It will be mole negative 4 liter 4. Okay? What I'm trying to show you over here is when you come across mole negative, tak payah tengok orang belakang, tengok mole je. When you come across mole negative, you know it's a M negative. M negative berapa? Tengok pada mole tu adalah negatif berapa. Dia negatif berapa? Bermakna dia adalah molar negatif berapa. Nampak? Okay. Back to one thing. Kenapa saya ajar unit K lama macam ni? Unit K will be one of the big tips in your question. From the unit K, you know the order. From the order, you can choose the formula. From the formula, then only you can solve the problem. Important. Okay? Boleh? Senang je? Tak susah, tapi kena tahu. Okay. Good. Reaction order. Nothing much. Reaction order over here, nothing much. Just we will focus on zero order. We will focus on first order. We will focus on second order. But we always have more than that. Okay, we always have more than that. Dia boleh tanya third order, dia boleh tanya fifth order. Tapi kalau third order, fifth order, dia biasanya dia takkan tanya pasal calculation. Okay, so don't worry about that. Okay, kalau calculation, zero order, first order, second order. Talking about reaction order, just nak ingatkan kamu, kita ada order of reactant. We talk about that just now. Kita ada order of reaction. So order of reaction adalah total. Pakcik ni adalah every reactant. Yang ni je saya nak kamu boleh bezakan. Okay, we talk about that. So right now, I want to give you one thing. If I have a rate equals to K, let's say balik kepada A to the power of 2, B to the power of 1. Simple, tak ada apa. Very quickly. So, order with respect to A adalah berapa?
2.
Order with respect to B?
1.
Alright, order with respect to B adalah 1. Ni cara biasa kita tulis lah, order with respect to siapa. Okay? So, total order?
3.
Tutup mata boleh buat betul. Problem arise when I give you the equation. Take a look at the equation. What would be the rate law if the equation is this? Adakah rate law saya betul sekarang? Any idea? Anything that you want to say? What is missing? Or is
C.
it right? Sorry, Umi?
C.
C missing. If you remember, rate law, kita ambil kira siapa?
Reactant.
Thank you. Dan sayang, kita ada berapa banyak reactant? Dan sekarang saya bagi tahu untuk equation ni, rate law dia adalah seperti yang saya bagi. Rate law dia yang ni je. Why?
C power of 0.
Because C power of 0 lagi tepat sikit.
Order with respect to C is 0.
Yes. Alright, order with respect to C adalah 0. See the difference? Ini kira level paling susah untuk reaction order lah. Setakat baca reaction order tu hang boleh buat. Yang ni je lah yang akan kamu suka tinggal. Alright, yang kamu tak perasan. Dia tak tulis bukan sebab dia tak wujud. Dia tak tulis sebab yang ni adalah kuasa 1 to the power 1 first order. Yang ni adalah kuasa kosong. Dan kita tahu apa-apa yang kuasa kosong akan bersamaan dengan 1. Betul? Sebab tu kita boleh tinggal. But what happen if the question is asking identify, just like if the question is asking identify the order with respect to each reactant. Apa jadi kalau soalan tanya untuk setiap satu reactant? Jawapan kamu tak boleh berhenti di 2. Jawapan kamu doesn't stop here. Jawapan kamu kena ada yang ni. Sebab kita ada 3 reactant. Makes sense? That is the trick. Okay? First order, second order, third order semua tak pernah jadi masalah. Yang akan jadi masalah adalah 0 order because we can miss it out. So be careful with anything that you don't have. Kita still akan tengok reaction. Kita still kena tengok reaction. Cuma kita tak ambil stoichiometry. Okay? And before we move on from your reaction order, before kita bergerak daripada reaction order, just a very big thing, the reaction order is not stoichiometry. Tolong ingat. Alright? Tolong ingat. It's never the stoichiometry. Okay? Never ever. Dia tak pernah ambil stoichiometry. Reaction order kita akan masuk banyak pada minggu depan di mana kita akan kira. Reaction order kamu kena calculate. And in our syllabus, you have 3 methods to calculate. We will talk about this next week. Okay? So don't worry, jangan risau dulu. Sekarang boleh baca dulu lah yang penting. Okay, done with that. I have one slide missing. Let me. Yep. Oops. Yep. Alright. Boleh? So, when you have your order of reaction, tulisan buruknya macam biasa, 0 first second. Kita pergi kepada rate law sikit. Your rate law will be R equals to K, R equals to KA to the power of 1, R equals to K to the power of 2. Ada orang tak setuju? Nampak kenapa R equals to K? Because it should be R equals to KA to the power of 0. Pakcik ni 1. Okay? Happy with that? Okay ya? Setuju ya? Tak ada apa ya? Okay. Going into your integrated rate law. Kalau dan kita akan buat satu soalan. Kalau tak dan saya akan tunjuk macam mana nak buat soalan tu nanti. Okay, kamu buat sendiri lah kat bilik, nanti kita bincang minggu depan. Integration, you're very lucky, you know. Saya tak tahu nak kata lucky ke tak lucky, because the less you learn, lagi hampa tak pandai lah. Good news is, you do not need to show the integrated. You only need to use. Okay, tak perlu derive. Sebab tu kat nota saya pun saya dah buang derive tu. I believe last semester mathematics chapter last ataupun this semester first chapter, kamu belajar integration. Betul? And integration means you always integrate to a limit, right? And what are we integrating? We are integrating the rate law to the limit of time. Why are we integrating it to the limit of time? Because the word rate we discussed on last Monday, the rate will be determined by time. We will measure it against the time. Sebab tu kita akan integrate to the time. And the first question for today, can I have, not the first question, many questions already. Can I have the integrated rate law for zero order? Anyone? Yes?
KT
Ya, sambungan ni.
concentration A 0 minus concentration A T.
Thank you. All right. Ifan? First order. Ifan hang betul ke line teruk ke my problem ataupun hang sebenarnya tak dengar pun kelas aku, hang tengah tengok enemy, hang tengah main game. Apa ingat aku tak pernah jadi student kot nah? When I was a student, I was even worse than you. But I still got 4 flat. Ifan will be the first person answering question when we see face to face. Laila?
First order learn concentration A 0 minus learn concentration A T. KP kat depan. KP equals
Okay, KT duduk depan ke belakang sama je. Tapi sebab Hani mula dengan KT duduk depan, so semua orang saya pun letak KT kat depan lah. Okay, KT kat depan ke belakang sama je. Saya suka letak KT kat belakang sebab KT tu tak berubah. Yang berubah orang depan. So saya nak kamu hafal yang depan dulu. Sebab tu nota saya letak concentration semua tu kat depan. Okay, sama je. Okay, it doesn't matter. So over here, KT equals to 1 over AT minus 1 over A0. Okay, so KT duduk depan ke duduk belakang, optional, up to you. Both are correct. Okay, talking about the KT first. Again, since kita tak payah belajar derive, so kamu kena hafal lah. Nak kena hafal, cara yang senang adalah look at them and look at their differences and similarity. Similarity, semua adalah KT. Betul? Dan sebelum saya move on kepada K and T, your KT, alright, unit K kat sini untuk zero order adalah M time negative 1. First order time negative 1. Apa bakar sampah ni? Pollution tu. Okay, setuju? Yang paling kena setuju. Betul? Time. Right? And the partner of the K is time. So, benda ni tak susah. Tapi saya nak ingatkan kamu, kalau K kamu bermain dengan masa, unit time kena sama. Contoh kalau kat sini adalah MS negative 1, which mean your time must be in second. Kalau kat sini adalah minute negative 1, bermakna your time mesti kena in minute. Kalau kat sini adalah molar year negative 1, then your time mesti kena dalam year. Benda ni adalah tempat yang kita akan main. The unit of time is the place that we will change your life. Sebab saya boleh bermula dengan 0.01 ms negative 1 for K value. Tapi saya bagi tahu masa adalah 2.7 minute. See the difference? And it change your life. Okay? So something very simple, something you know but don't do the careless. Okay? Done with the KT. Simple, benda yang kamu boleh buat. Next that we are going in adalah this A0, this A0. Kalau kamu perasan, formula kamu untuk the zero order and first order was starting off with the A0. Okay? A0 minus AT. Tapi untuk second order dia terbalik. 1 over AT minus A0. See that? So semua adalah A0 minus AT kecuali second order. Second order adalah 1 over AT minus A0. Okay? Laras, nampak yang tu? Make sure nota kamu semua formula sama dengan saya kat depan ni. And then next, the knot is pretty simple. The knot tak ada issue, initial. Alright, the knot is initial. Nothing much, nothing to argue over that. Yang kita akan argue adalah T. Apa benda tu concentration T? Concentration T is what left. Alright, concentration T is what left. Bahasa senang, when I was a student, cikgu saya ajar, T tu yang tinggal. T tu mesti adalah concentration yang tinggal. Okay, what I mean, I can start off with the initial, concentration initial, 1.0 molar. Reaction started, reacted, betul? Reacted adalah use, so I use 0.4 molar. How much is left, guys? 0.6 molar. Nampak? So initial kita adalah banyak mana yang kita mula. The one that we use or the one that reacted or the one that you have decomposed is the one that changed to product. How much is left is the one that we want. Nampak? Okay? So, kita ada 5 more minutes. I want to go for question. We just tak saya buat, kita baca soalan je. Okay, kita baca soalan je. Oh my god, siapa bakar sampah? The initial concentration of A 3.5. So, I started off with concentration A initial 3.5. Setuju? Okay. Read the question for B. How long? Obviously, we are looking for the time. How long will it take for the concentration of A to drop to? The concentration of A to drop to 1.0 molar. So my question, 1.0 molar is the one used or the one left? Anyone?
Left.
Left. Okay. Concentration of A drop to, jatuh sehingga. I use until the concentration left with 1.0. So the concentration AT is 1.0. Nampak beza? Okay, yang ni okay lagi. We move on a bit. Tengok soalan je. Okay, this one. Yang ni saya memang tak nak buat. Ada, soalan ni ada. Kita bincang next week. Nanti kamu buat lah. Cuma kat sini. Question B. Calculate the rate constant K. We are calculating the K. The K is how much? If 5% of SO2Cl2 decompose. 5% of SO2Cl2 decompose. Dia guna percentage. So saya nak kamu senang nampak, saya pun guna percentage. Initial, obviously 100%. Okay? Alright, kita guna percentage. Soalan saya, 5% is the one left or the one used? Bahasa Inggeris je ni. 5% decompose. Lim?
Use.
Use. 5% decompose sayang. Perkataan decompose represent use. Represent reacted. Represent depletion. Alright? Represent digunakan. Apa lagi bahasa apa nak? I don't really speak Chinese. I mean, I speak Chinese, but I learned BM and English way earlier than when I learned my Chinese. Yeah. Thank God I'm working in Penang, so I pick up some Chinese. I speak Chinese, but not so fluent. But yeah, if you want to scold me, Lim, you can really scold me in Chinese, and I'll be like, okay. I might understand lah now after like so many years in Penang. Okay, so decomposition is this. So the 5% is the one that use. Okay, so we use 5%. How much is left? Simple mathematics. Betul?
95.
This is initial. This is the one left. See the difference? So, formula tak susah. Formula tak pernah susah. Formula tu senang je. Senang satulah, hang hafal lah. Senang-senang pun hang kena hafal lah. Okay? Formula tu senang, kamu hafal lah. Okay. Yang akan jadi problem kat formula ni adalah your KT. Okay? Yang ni yang akan jadi problem. Masa. Saya ubah satu benda je. From MS, I change to M minute. You're done. Okay? That is the trick where we will play along in the exam. Second thing, this one. Alright? Not tak pernah jadi masalah. Initial senang nak identify. How much we start off with. Betul? The problem always arise adalah pada concentration yang dia bagi seterusnya adalah yang use atau left. So you need to be very careful with this thing. The one that I'm having right now is the one that use or the one that left. Make sense? Dan saya selalu conteng benda ni. Kalau kamu tengok minggu depan bila saya buat soalan pun saya akan conteng. Saya budak tak pandai, saya conteng lah. Kamu budak pandai, semua benda dalam otak. Alright? Make sense? Simple? Okay. So, nothing much. Just very, very quickly going through the conclusion a bit. Before next week, we are going to do the question. We have order. We will focus mainly on the zero order, the first order, and the second order. For today, we talk about rate law in detail. I hope you can differentiate your rate law and your differential rate equation. And then your first concentration A to the power of 1, second RK concentration to the power of 2. Then we move on to the unit K. Unit K, very, very important. Because from that, you need to identify, what they are. So yang ni adalah time negative 1. Yang ni adalah negative 1 time negative 1. Kenapa yang ni penting? Sebab yang ni akan menentukan what formula you are using down here. Alright, dia akan menentukan pakcik ni and we talk about that. Dan saya memang biasa letak macam ni. Mana-mana yang kamu nak guna, nak tulis KT dulu pun tak ada masalah. Just my habit, nothing much, just my habit. Okay, tak ada apa. So over here adalah ln concentration A0 minus ln concentration AT. Jangan salah formula. Over here, 1 over concentration AT minus 1 over concentration A0. Don't do mistake on the formula. Okay? I really hope that you understand on how to use it and the trick behind every question. Moving from the integrated rate law, you can have half-life. So, your homework, of course, is the question. Saya rasa tutor kamu tak banyak soalan. Tutor kamu ada soalan 7 ni je. Kalau buat satu soalan ni boleh pandai, aku tak ada kerja dah weh. Aku kena pencen dah weh. So, sila bergerak ke extra exercise saya. Okay? For example, for this question, how do you know which integrated rate law you need to use? Last question of the day.
Unit of K.
Unit of K. And what is the unit of K?
S negative 1.
S negative 1. Betul? Therefore, what order is this?
First order.
First.
Nampak? So you need to know the order of the reaction before you determine the formula that you use. Okay? Makes sense? Nampak dah sikit cara nak guna? Better a bit? Okay? Ada lagi benda extra, a few more things yang kita akan bincang along the way when we come across that question. Okay? Ni adalah benda basic, the very basic and the place that you will do careless. Be very careful and don't do that careless. Contoh okay, yang ni adalah in minute. So bila yang ni adalah in minute and you want to find the rate constant for the first order, okay, so bila kamu kira K, soalan B ni dia tanya K kan? So the K unit, jawapan akhir yang kamu dah kira, dia kena datang dengan unit apa? S negative 1? Tak, dia akan datang dengan, nampak? Okay, sebab kita guna minute. And of course, if you tell me, teacher, kalau yang ni saya darab 60, saya tukar kepada saat. Baru saya masukkan dalam formula. Boleh. Then your K will have a different value in S negative 1. Nampak? Okay, kita pergi kepada benda basic dulu lah dan kita akan, ni bukan soalan 2 je tau. Dalam nota saya ada banyak lagi soalan. Saya ambil 2 soalan ni sebab saya nak bincang 2 soalan ni punya trick sahajalah. So do the exercise 1.1.2. Then next week I'll see you on Monday morning as always. And we always have quiz on the 2-hour class. Okay? Boleh? And from there, finishing this, we will then be going into graph. And next week, we will be also going into your 1.2 and 1.3. 1.2, 1.3 dia sekali. Saya nak ajar sekali, dia benda yang sama je. Lebih kurang sama, related. Okay? Alright, so nothing much on here. If you have any question, feel free to WhatsApp me. Okay, saya layan je. Kalau saya tak layan, sama ada saya tengah buat kerja. Kalau message yang kamu tanya soalan dan saya tak layan lepas 6 hours, lepas half a day, sayang, saya bukan belagak, saya lupa soalan kamu. Kamu message lah balik. Okay? Alright? Saya banyak kerja, kadang-kadang saya tengah drive ke apa, bagi tanya balik soalan tu. So feel free to ask question. Okay? So nothing else. Enjoy your lunch. Have a good day and I'll see you guys around. Okay?
Thank you, madam.
Thank you. Have a good day.
Thank you, madam.
Thank you, Miss.
Madam.
Ifan tak nak cakap thank you ke Ifan?
Thank you, madam.
Thank you, Miss.